Now let's try to answer this question. For the lattice given below, how many complements does the element E have? And options are given 1, 2, 3, 4. Okay, so this is the lattice given and they are asking about number of complements that the element E will have. So if you look at the element E, this one, how many complements will it have? So just see this. G cannot be complement, B cannot be complement, and A cannot be complement. It is very clear, isn't it? Because E and G, they meet at E itself, they are not going till A. And E and B, they join at E and meet at B, they are not going till A. And again E and A, they join at E itself, they are not going till G. Therefore, they cannot be complements. Now look at E and D. E and D, they are joining at G and they are meeting at A. Therefore, one of the complements for DE is D. D is a complement. And what about F? E and F, they are joining at G and they are meeting at A. Yes, therefore F is also a complement. And what about E and C? E and C, they are joining at G and meeting at A. Therefore, D, F and C, all these three are complements of E. Therefore, how many complements are there for E? 3 complements. And now you have clearly seen that one of the elements is having more than one complement. Therefore, we can say that okay, the question is solved. The answer is 3 over. Now I am just taking it a bit forward. Now from this question we can even derive some other points, even though they have not asked. I just want to do this. See this? Now for this particular element E, we have got 3 complements. So what can you say about this lattice? It is not distributed, because in a distributed lattice we can have at most 1 complement for every element, but here we have 3. Therefore, this particular lattice is not distributive. Now, is it complemented lattice? Let's see it. How can we know that a lattice is complemented? If there exists a complement, at least 1 complement for every element, then we can say that it is complemented lattice. Let's see this one. E is having complements D, F and C, and D is having complements E and F and C, and similarly C is also having a complement E. And what about B? B is also having a complement, because either you can take D or F or C, right? B is having either D or F or C as a complement, and similarly C is also having complement. What? Either D or E or B. F is also having complement, either D or E or B. You can check it. It is just trivial. That is why I'm not explaining. It is just so visual from the diagram, right? And A is having the complement, which is G, and G is having a complement, which is A. So here every element is having at least 1 complement. Yes, for some elements there are more than 1 complements, but that is not important. What is important here is every element is having at least 1 complement. Therefore, it is definitely complemented lattice. It is not distributive but complemented. Now, in the earlier example, we have seen some example. What was that? D18. If you see D18, tell me what type of lattice it is. So here there was 1, 2, 3, 6, 9, 18. D18 and divides is the relation. In the earlier example we have seen this one. Can you tell me what type of lattice is it? Is it distributive lattice? It is distributive lattice. Even though it might look like, you might think that, see, one thing is for sure, every element is having at most 1 complement here. For example, how many complements will 18 have? Only 1. How many complements will 1 have? Only 1, right? I'm just putting them in the brackets. So 18 is the complement of 1 and 1 is the complement of 18. How many complements does 3 have? I don't think that 3 is having any complement in this case. Yeah, 3 is not having any complement, 0. How many complements does 9 have? 9 have 1 complement, which is 2, right? And how many complements does 2 have? 2 have only 1 complement, which is 9. How many complements does 6 have? 6 have 0 complements. 6 is not having any complement. So 3 is not having any complement and 6 is not having any complement. Therefore, it is not violating any rule that an element is having more than one complement, so it is a candidate to be a distributive lattice. But then I cannot straight away declare that it is distributive lattice. In most of the cases it will be, but let's just be cautious. So let's see if either L2 star or L1 star is a part of this, is a sub lattice of this. If you can check it, it looks as if they are part of it, right? Which means you might feel that L2 star is a sublattice in this, but then it is not a sublattice. It is just a lattice but not a sublattice, isn't it? So this one is, if you remember, this one is L2 star. So let me say it is 1, this is 3, this is 6, this is 2, and this is 9. So I cannot take this. Let me say this is 9 and this is 18. Okay. So it looks as if this particular example, it looks as if it is going to be a sublattice, right? If this particular lattice, which is a subset of this, is a sublattice also, we can say that it is not distributive because it is L2 star, but then it is not a sublattice. The reason is, in the given diagram, if you see, the greatest lower bound of 6 and 9 is 3 because they are meeting at 3, but here greatest lower bound of 6 and 9 is 1. Therefore, even though we have a subset like this, it is not a sublattice. Therefore, it is not violating any principle. So this one is clearly distributive lattice. What about complement? It is not complemented lattice. The reason is simple. So it is both, see this one is having 0 and this one is having 0 complements. In a complemented lattice, every element should have a complement, but here we don't have complements at all. That is why it is not complemented lattice. Are you understanding this? So this is an example of a lattice which is distributive but not complemented. This is an example of a lattice which is distributive but not complemented. It is which is complemented, it is not distributive. Now, can we frame any example which is neither distributed nor complemented? And can you frame any example which is distributed as well as complemented? Let's see this. Now let's try to frame an example which is neither distributive nor complemented. G, this is E, this is F. C. Let's try to frame this one. I think this example, let's see this one. Okay. In this one, how many complements does E have? E is clearly having, one is okay. So how many? Let's see one by one. I am talking about the complements of E. So D cannot be complement because they are meeting at B, and F cannot be F can be complement because both are joining at G and both are meeting at A, right? And what about C? Yes, C can be complement because both are joining at G and this. So E is having two complements. So what can you say about it? It is clearly not distributive because one element is having two complements. It is clearly not distributive. Now, what is the complement of D? If you look at D, E cannot be complement because they are meeting at B, and F cannot be complement because they are meeting at C, and D cannot be complement because they are directly related, isn't it? Therefore, least upper bound and greatest lower bound are going to be B and D itself, and the same thing applies for here also. A cannot be complement and G cannot be complement. So the complement of D, number of complements of D is 0. So there is an element which is not having any complement, so it cannot be complemented lattice. Got it? So now a lattice can be only complemented, a lattice can be only distributive, or a lattice may not be neither, right? It may not be distributive nor complemented. Now, can we frame an example of a lattice which is both distributive as well as complement. Now see this one. Let's say A is a set. I'll take a small example. A is a set having two elements. Then I want to see what happens with power set of A, and then set inclusion is the relation. Okay, so you can try this example using three element set A, B, C, but I'm just, for the sake of simplicity, taking a small example. It doesn't mean that for bigger examples it will fail. You can take a bigger example also. Okay, but just for the sake of simplicity I'm taking this small example. Phi A, this is power set of A. All the elements of power set of A I am representing in a lattice using the relation set inclusion. Okay, AB. Now if you observe this one, every element will have a complement here. The complement of this one is AB, right? And complement of this one is B, and complement of this one is Phi. So every element is having complement. Now if you check it, the number of complements here is 1, 1, 1 and 1, and it is distributive as well. The reason is, one reason is simple. On the on any set of sets, on the relation subset, the join is going to be union and the meet is going to be intersection, and we know that union is distributive over intersection and intersection is distributive over union on sets. Therefore, whenever you come across this question, you can definitely say that it is distributive, right? So one rule is, since we are talking about these sets, we know that union and intersection are nothing but the meet and join here. So it is, both are distributive on one another. Therefore we can say that it is distributive. And since every element is having exactly one complement, or every element is having a complement, I can say it is complemented. And one other way of saying it is, complement, we have proven it. Since it is having only 4 elements, every lattice with 4 or fewer elements is distributive, right? But that is not a good logic to apply here. Here the best logic is, even if you go for A, B, C, and if you get 8 elements also, if you have A, B, C, and if you have 8 elements also, then also this particular poset is going to be distributive as well as complemented, because the simple fact is union and intersection are distributive on one another. That is a good logic. Okay, so anyway, whatever logic you use, you can show that there is an example of a lattice which is both distributed and complemented. So since it is distributive and complemented, it is also a Boolean algebra. What is a Boolean algebra? If a lattice is both distributive and complemented, it is Boolean algebra. This is not Boolean algebra, not Boolean algebra, not Boolean algebra. Got it? So I think I have given you examples of each class. A lattice which is only complemented, a lattice which is only distributed, a lattice which is neither complemented nor distributive, a lattice which is both complemented and distributive, and therefore Boolean algebra. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.